Hello, let's take a look at how we would be dividing decimals by whole numbers. We continue looking at operations on decimals. This is our textbook, Singapore Math 5B, and we are on page 22. So let's look at the examples in exercise 8. Notice again, we're only dividing by whole numbers. We're only dividing by whole integers. We are not dividing by anything more challenging. First, we're going to look at the patterns as before. So let's do the first four examples. A, B, and C. I hope you see how as we move forward from A to the B to the C to the D, we notice a certain pattern. 40 divided by 8 is 5. That's third grade. 4 divided by 8. Notice, to prove what we are getting here, we can write it as a fraction. We know that fraction and division are the same operation in mathematics. We can write horizontal division as a vertical fraction. And notice that it results in 1/2. And we do know 1/2 in the decimal format is 0.5. So that's one way of looking at it. 0.4 divided by 8, or 4/10 divided by 8, results in 5/100. And finally, 4/100 divided by 8 results in 5/1000. Let's take a look at decimal places. We have 0 decimal places, we have 1 decimal place, we have 2 decimal places, and we finally have 3 decimal places in example D. Notice, as we keep dividing by the whole number, our quotient is getting smaller and smaller, which is how division by whole number works, right? We're splitting something into smaller equal groups. Now let's take a look at E, F, G, H. In example E, we have a similar situation. 42 divided by 7 is 6, but 42/100 divided by 7 is 600. Now, look at example F. 42 divided by 7 is 6, but 42,000 divided by 7 gives us 42,000. Okay, 6,000. Now, let's take a look. 8.1 divided by 9. Well, 81 divided by 9 gives you 9. 81/10, right? That's what 8.1 is. 81/10 divided by 9 is 0.9. And take a look. 81,000 divided by 9 is not just 9, but 9,000. 3 decimal places. I hope you're seeing a pattern. We don't need to do too much work here because all the numbers are very small and we can figure out the quotients using our knowledge of multiplication table. However, let's take a look at the following example. 8.1 divided by 6. Here is where I would like to use our long-term friend, long division. Long division is the tool that we will be using for solving more challenging division problems, just like we do with whole numbers, right? When we're trying to divide whole numbers that are not easily divisible, we use long division. So let's write it down. 8.1 divided by 6. Step 1, proceed with division and try to ignore the decimal points. So let's go. 6 goes into 8 one time. 6 times 8, 6. Find the remainder, 2. Bring down the next digit is 1. But notice what just happened. We just crossed the border of the decimal point. We must, before we place the quotient, we must put this decimal point in a similar place inside our quotient. And now we can continue with division. 6 goes into 21. 3 times. 6 times 3 is 18. Remainder is 3. Are we done? No. In 5th grade, we are not looking at remainders anymore. We're going to divide by adding trailing zeros. Now, does 6 go into 30? Yes. How many times? 5 times. 6 times 5 is 30. And of course, the remainder is 0. My friends, notice how we divided 8.1 by 6, and we have the quotient of 1.35. We used long division. We used long division to compute our quotient, which, we deployed many times before when we tried to solve more difficult examples. Let's practice long division for decimals, okay? I jumped over page 23 and I'm now on page 24. I'm going to write it down. On page 24 of our textbooks, let's take a look. Number 10, step 1, estimate. Number 11, step 1, estimate. Number 12, part A, estimate. Again, we're going to look at estimation methods to see if our answers are reasonable. Let's do part 10, question 10. 3.61 divided by 5. Let's think 3.61 for division. Instead of rounding up, we're going to round to the closest division fact. What is divisible by 5? 3.5 is divisible by 5. 3.5 is very close to 3.61. Again, notice we're not rounding to 4. We're not rounding to 3. We're rounding to the closest division fact. 3.5 divided by 5 is 0.7. Now, let's employ long division. So this was part 1. And let's do long division to find the actual value. So step 1, we estimate. Step 1, we estimate. And then part 2, find the value. Find the value. Find the value in all of these examples. And I'm going to lead you through them. So let's write it down. Let's write it down. 3.61 divided by 5. Again, let's follow the long division algorithm that we've known since 3rd grade. Does 5 go into 3? No. Does 5 go into 36? Notice at this point, I still ignore the decimal point. Does 5 go into 36? Yes. How many times? 7 times. Except, my friends, we just crossed the border of decimal point. We must put it into our quotient. Okay, and we can put a 0, right? We can put a 0, we can skip that 0, right? So notice, we must place the decimal point into our quotient as soon as we cross that barrier. But then proceed as normal. 5 times 7 is 35. Subtract. We have 1 as a remainder. Bring down another 1. 5 goes into 11 2 times. Are we done? No, we're not done. We're not done. And we have 1 as a remainder. Let's put a trailing 0. Let's put a trailing 0. No remainders anymore in 5th grade. We continue dividing. 5 goes into 10. 5 goes into 10 2 times. Yes, 5 times 2 is 10, and the remainder is 0 now. So the answer for this problem is 0.722 or 722 thousandths. Notice how our quotient is very close to our estimate. Let's practice some more. Let's take a look at question 11. Step 1, let's go ahead and estimate first. Let's go ahead and estimate. So 22.11 divided by 3, I would think of it as 21 divided by 3 should be about 7. 5.04 divided by 7, I would think of 5. 5 divided by 7, we should have something around 0, right? 7 goes into 5 0 times. 27.08 divided by 4, let's think of it as the closest division fact is 28 divided by 4, and we should have about 7. Now, I'm going to continue estimating for D, E, and F. 1.14 divided by 6, well, does 6 go, let's say 1 divided by 6. 6 does not go into 1, so our answer should be 0 something. 0 something, but definitely 0. Starts with a 0 holes. And 8, right here, it's about 8 divided by 8. Our answer should be, quotient should be around 1. And finally, 816 thousandths. How would we estimate this one? Let's just say it's about 0.9 divided by 3. Notice I'm rounding it close to the closest multiple of 3, and our answer should be about 0.3. My friends, for all of these examples, A and B and C, you should be using long division. So I'm going to do just one of them, and then let's do just one. I'm going to do part A. So let's just find some space right here, part A, right here. 22.11 divided by 3. 3 goes into 22 7 times. 3 times 7 is 21. Remainder is 1. Bring 1 down. Notice we're crossing the border of the decimal point. Let's put it into our quotient and moving on, continuing. 3 goes into 11 about 3 times, right? 3 times 3 is 9. Remainder is 2. And again, we bring another 1 down. 3 goes into 21 7 times. 3 times 7, 21. Remainder is 0. So the actual quotient for example A is 7.37. And so on, and so on. I hope this is starting to make sense to you. Now, look at the example 12. Again, all the examples in part L in the question 11, A, B, C, D, E, F, you should be solving using the long division, just like example A. Now, when it comes to exercise 12, they're asking us to divide 21.36 by 9. Well, we know that 21, which closest fact multiplication multiple of 9, it's 18. We should have about 2. That should be your estimated value. And how to divide correct to specific number of decimal places we will cover in the next lesson. I hope you find this video helpful.